So this is like an illustration that I made to show all of the outcomes of rolling two d6, two six-sided dice. So you can see like a 1 and a 1 on one side and a 6 and a 6 on the other, and in between is all of the other combinations of stuff. And obviously the most common is 7. So if you're going to guess the outcome of a 2d6 roll, your best guess is 7, but it's still random. You still can't be certain that that's going to be the case. And this is like I mean, I can explain why it's 7. I did another thing. This is the other thing. This is why 7 is the most common. Like if you imagine, I should have illustrated the axes here, but like if you look along the very top dice, this is 1, 2, 3, 4, 5, 6, and the top dice is like that on every row. So 1, 2, 3, 4, 5, 6, and the bottom dice is 1, 2, 3, 4, 5, 6 vertically. So you can see like every combination of the two dice, and 7 goes right down the diagonal middle, and there's just more squares that for that than there is any other number. So even though you can roll as high as 12, it's not it's as likely to happen as rolling a 2. So yeah, I'm going to be using Any Dice to do a little more illustration. If you don't know Any Dice, it's a website where you can input like a dice roll and see the statistics for that dice roll. It's super good if you're like making role-playing games or just want to play around with the concept of dice. So anyway, this is that 2d6, 2d6 dice. So it starts out at 2, 3 is a bit more common, and so on and so forth. 7 is the most likely, and then it gets less likely again as well. And you can see what happens if you just put in a 1d6, like a single die. Every number is equally likely. It's a flat thing. But if I do 3 dice, there's obviously more numbers that you can get. You can roll as high as you can roll at least up to 18 in this. There we go. But it's not like a point or a flat thing. It's turned into like a bit of a curve. And and as you increase the number of dice you roll, so let's bring this up to 4. Boop, boop. You can see it's even a bit more curvy. It's like going into this bell curve. And this is, I think it's called the, there's a theorem for this. I've completely forgotten the name. But basically the more random things you start to stack together, the more the curve approaches this what is a normal distribution, a Gaussian distribution. So this is what 10d6 looks like probabilistically. So like the odds of getting like even a 15 or lower have become very, very small, and the odds of, you know, getting the central thing have started to increase. I mean, they've not increased the relative. I don't have the words to describe it, but you can see like if I was to put in 100d6, this might give it a minute. Yeah, it's become very narrow, and like anything less than 300 is very, very unlikely. It's not the law of large numbers, is it? I think that might be related, but there's you know what? I hate to do it during the stream, but let's look up Wikipedia. Central limit theorem. There we go. That's what I wanted. But it's obviously like I've got like it might not be apparent for how much I'm talking about dice and numbers and statistics, but I have dyscalculia, so this is beyond me. But I'm pretty sure that this describes the way that if you add more dice, more and more it approaches this curve. So like if you are randomly sampling dice, wow. So this is basically working out every possible outcome is what Any Dice is doing right now. It's not actually rolling 100d6 a bunch of times to see all of the different sums that it can get, but it's telling you Maths Wikipedia is hell, lol. Yeah, I mean, even if it wasn't, I wouldn't be able to read it. Like, you'd need to put this into like pseudocode for me to understand what any of it's doing. I'm not familiar enough with the symbology, the language that it's using. It's just not in a format that I understand. Bunnies. Anyway, so this is basically what I've been thinking about lately. Is normal distributions and dice rolls, and obviously normally when we're selecting a date for a random date for this event, I will normally pick a number between 1 and 365, and it will normally be like one of those flats, you know, like the 1d6 completely flat. So a relatively even chance of getting any outcome. Sometimes I will randomize the month to select a month and then a day within the month. So that means that it's a bit more bumpy. Bunnies. But this time I've decided I'm going to just roll d6s. So let me just switch my scene here. So here is what that curve looks like on top of a calendar for 73 d6s. I will be rolling. I'll be rolling each of these and counting sixes as 0. So each d6 will give me a random number from 0 to 5, because the sixes won't count. This is some John Boyce shit. So that gives me a number from 0 to 365. If it is 0, then that will start over. But the odds of rolling 0 73 times in a row is, hey Martin, it's incredibly unlikely. So yeah, this is what I wanted to explore today, is this idea that this is going to be a random selection. It's you can't expect the outcome because there's a range, but it's not entirely unpredictable. Real dice, yes, I'll be using real dice. I have set the category to Sophie's dice, but like technically these are Sophie's dice, so I'm not lying. Where was I? I think I've just lost myself. Yeah, so if they all turn out 0, I will just start fresh. But the odds of rolling 0 73 times in a row are so unlikely that I think it's one of those things where you'd have to be rolling dice for the length of the age of the universe several times over, like an absurd amount. I'm not going to do the calculation. It is just incredibly unlikely. Wow. I mean, like what I've done here, I'll just demonstrate that it is the same curve as before. It's just a little squashed vertically, but that's just a scale issue. This is each day of the year is one, following the next. Wow. But I'll be showing it on the calendar here. So yeah, the idea of rolling 0, if even just like rolling a single 1 and then the rest zeros, is like such a small number that, like, as far as this is concerned, like that's a 0. Like that's beyond calculating. But yeah, this is like the interface that I have made for it. You can see in the bottom left which roll we're on. It will also update like the minimum and maximum possible dates for how we're doing. So it is going to be 73 dice rolls, and it will also show the expected date there as well. At the moment, it's actually like halfway between July 1st and July 2nd, but it rounds down. It's not really a major concern. It's just when it gets to gets to the end, we'll have an exact thing. Wait, does this mean it's likely next year's RNG day will be in June or July? Precisely, yes. It is random. It could be any day. Like it's physically possible for it to be January 1st or December 31st. However, physically possible is not necessarily statistically possible. It's, I think, what statisticians would call an impossibility. Like, it's statistically impossible. You know, we could be rolling we could be doing this for several lifetimes of rolling and still never see those results, just because they're so incredibly unlikely. But that said, it's still random because we don't know what it's going to be. We can see which days are more likely. Bloody. And this will adjust. Like, let's just simulate rolling 5 a bunch of times in a row, so you can see, you know, the predicted outcomes adjust based on, you know, however we're doing. And if I was to roll, only 6s, which are 0s, you know, that adjusts that way too. And eventually we'll narrow to a single value after all 73 rolls, and that will be the date of next year's RNG day. Thank you. Like, I did put a fair amount of effort into making sure that this was going to work, and hopefully it will. So I suppose we'll see. I'll need to just move my move these dice over and bring out my dice tray so that I don't have dice flying everywhere. And just this roll doesn't count. I'm just testing that the cameras. Let me just see if I need to autofocus that. Like, I just. I mean, that seems fine, right? We can read that. But a 6 on the test roll is lucky, so that's good. Not only does it work, but it looks very satisfying. That's great. I mean, I don't know if it works, but I'll take your word for it. I mean, you can. I'll try and make the source code for it available on the website after, or like later today probably, and you can have a look at it, or you could just, you know, watch a VOD and do the math yourself if you're really interested. Anyway, so I suppose I'd better just start rolling. I'll roll these the 3 orange ones first, because I mean then I've just got like a nice 10 at a time. So we'll see how we do. Let's roll. Yes, first number 1. Okay, that could be better, but you know, it's something. So you can see whilst we're here, like now we're at least sure that it's gonna be some number in the next year. We're not gonna have to get zeros all the way through and then restart. But yeah, you can see the red markers show the limits of where we can be with this. A 3. How exciting! Sorry, I'll leave the dice in for a little longer so that you can see them before I shuffle them off. Okay, and let's not waste time. I'll keep it in. 3. Like I'll do these 10 at a time because they're a 6. That's 0, unfortunately. I get excited when I see a 6, but like then I remember, no Christmas RNG day. No. It's that's just one of those things that we have to deal with. It hasn't happened yet, but it could happen, but not 2025. That's it's gonna have to be another year. 20s. Also, if our first 5. If you see me like forget to input a roll, I mean I can actually check it after each 10, can't I? Because it says in the bottom left there how many rolls I have. And there's a 1. Goodness. Another 1. Okay. This is definitely skewing June. Booty. 3. Wow, I've got shoes on. The expected roll for any single dice with this setup is 2.5 if you are curious. Normally it is 3.5 for a d6. You know, the mean between 1 and 6. But because we're subtracting 1, we're not counting 6. It goes 0 to 5. It's a different mean. That is a 2. Okay, our first 13 down. And we've ruled out December and most of January. So, you can see, like, I did a lot of work to, like, make this adjustable and show, like, oh, like, if the probability did go all of the way to December, then all of the bars will adjust and stuff. But in reality, it's just not going to do that much because it's very unlikely. I will lol if we just get July 1st. I mean, I was considering doing another method which is similar to this but more likely to come up with that, which would be to roll coin d2s, you know, just flip a coin. So heads add 1, tails don't add anything. And ooh, high incidence 73. Yeah, I've been doing well, thanks. Yeah, so that would make, you know, a greater number of random occurrences to sample. So the curve would be even more pinched, so more likely to trend towards the center. Boo, boo, boo. I think, actually, now that I do it, I'm gonna have to check that at some point. Anyway, it's time for us to roll some more dice. Wow, another 1. I mean, it does feel like we're trending downwards, you know, like we've not even eliminated any of February yet. Wow, 4. Okay, there we go. That's more like it. Wow, it's Tuesday. I do have a tick where I say that it is Tuesday, but it's fortunate because it is actually Tuesday today. Hey Proust, going to the big city to go normal distributions. Yeah, it has been mentioned that it looks like a city, and I think that it is cool. Next year, just get a D365 and roll it once. I mean, I am tempted, you know, like I have many absurd dice. Please. Ooh, 2 6s in a row. Ugh. Excitement. Ooh, 3 6s in a row. That's 3 zeros. It's definitely trending downwards. Wow. Ugh. And a 2. Whoa. And a 5. There we go. An actual big roll for this set of 10. Boo, 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 boo. You've won. There's November gone. I mean, it's expected, but it's sad to see. I like November. Okay. Let's keep it going. Boop, boop, boop. A 5. 5 is as high as these go. Nice big round. Another 5. See, this is something that I like about. Whoa! Totally dropped that. This is something that I like about strings of random numbers. People expect that there won't be like many repeats in a row. But if you can expect not many repeats in a row, then that part of the selection isn't random, you know? So, So it is expected that there would be sometimes, depending on how long you're going for, and like I say, like this is why I made the distinction between statistical impossibility and physical impossibility. Like, it's not physically impossible at all to roll, 365 6s in a row. Like, that could happen. It could happen. But, like, because of the statistics. The probability of it is so unlikely that you can confidently say it's not going to happen. But anyways, I guess 1 out of 36 rolls will have equal dice in a row. Did you actually do the maths on that? That's cool. Okay. Wow. Where are we at? We're 33 in. Yes. So 40 left to go. Wow. And just to like compare and contrast, you can see that the range is definitely narrowing, but it's still staying right there. Like it's moved a little to the left, I think. Oh no, it's actually moved a little bit up. Like it looks like July 3rd is the most common now. Originally it was like July 1.5. That was our initial most likely outcome, our expected outcome. I don't know. I'm not a statistics scientist. I like the idea of the statistics scientist. Isn't it just 6 times 6? Yeah, I don't know. As mentioned earlier, I got me the dyscalcular. Bloody. A 5. Nice big 5. Hey. Dun dun dun. Boop, boop, boop. Honestly, this is nice just as an excuse to roll dice. I like rolling dice. It's pleasant. If you've already rolled snake eyes, the chance next time is 1 in 36. Is that because it's the same? Wow. Yes, we're being very careful not to assume that the dice have any memory of what their friends have rolled. I have decided to use a separate die each time, so that if there is any individual bias in each die, it is mitigated by potential other bias in other dice. So will the curve flatten as we go then? Yes, it will become less pinched up until there is only 1 dice roll left, and then it will be completely flat because each of the possible numbers that the dice can roll is the same. Like there's no additional dice to add more variation. A5. Wow. 2 snake eyes in a row up front, however, would be 36 times 36, wouldn't it? Wow. Yeah, it's a very slim chance. Yeah, definitely. It's one of those things. Like if you roll 2 snake eyes, the odds of getting it next time is the same as it was just before. But the odds of rolling 2 snake eyes in a row before you've done it is different. which is a tricky thing to wrap. Whoa, that was a complete miss. It doesn't count if it rolls out of the tray. Certainly not if it rolls off the table. I know that some game masters say, hey, play it where it lands. I'm not such a person. If I get an excuse to roll the die again, I'm gonna roll the die again. That's a 4. I wonder if it's possible to build a dice rolling machine that rolls very precisely and therefore is likely to give similar results. It would be interesting if it turns out that the results are still random, even though the throws are very similar. It's a 3, trust me. I mean, it's... It depends on your tolerance for certain things. I mean, the simple thing is, yes, it's absolutely possible. Like this does not count as a roll, just this next one. So like, if I had a dice machine that did that, like that's hardly a thing. Like I can predict what that's going to be, but I can't predict that. Like that's has a lot more. Jostling. I mean, the way I like to think about dice is like the ideal die you know, is perfectly fair, perfect, like it would be a perfect object, a perfect cube. Like I actually have some casino dice which are about as close as we can humanly get to this. But the point, the source of randomness is not from the die itself, but it's from the messy universe that we cast the die into. So the more it interacts with this messy universe, the more unpredictable things are happening, because we just can't keep track of the fine-grained detail of all of the different things. Like there's molecules, air currents, there's, you know, all kinds of different things. Like there's this felt surface has like tiny, you know, millions of tiny little fuzzy bits. I don't, and each of those is going to affect the die. The way that I throw is, you know, there's all kinds of things that go into it that are beyond our comprehension. And that's our source of randomness. So in theory, you know, like if if the fundamental universe is deterministic, then dice rolls are also deterministic. But I don't know, like my current understanding of like quantum physics, which is very narrow, would suggest that even on the smallest scales of what the dice interact with, things are still random. However, wow, that was a close. That one almost bounced out. I've got chips. However, this is what we are doing right now is a relevant thing to think about when you're thinking about quantum mechanics, of like how things seem random at smaller scales, right? But on the larger scale, things seem kind of predictable. You know, like you know, I let go of my pen, it's going to drop. Like that's not a surprise, and that's because like random things in aggregate, like when you sum them together, like we're doing here, like each die roll is random, but the sum of the dice rolls, because of statistics and you know, just the way that works, that some things become more likely, and at a certain point, when you add enough randomness together, things become like incredibly predictable, incredibly reliable. Wow. So, like, you know, if you subscribe to the many worlds interpretation of things, that you know, there's for each dice roll I do, there's like another universe where every other result is happening. Then, wow. Then, you know, every possible outcome does happen. But the majority of the outcomes, like the vast majority of them, are the ones that we're looking at here, or at least that are presented in the statistics. Wow, bunnies. And so the odds of like which universe you're going to find yourself in is oh, hey Sophie. I'll do a quick summary. I am rolling d6s, 73 of them, to generate a number between 0 and 365. So right now we can see that we have made 53 rolls, and the sum of that is 149. So the 149th day of 2025 is May 29th. And even if like every die roll from now on rolls a 5, it won't go further than September 6th. And, you know, like, I know that you know about normal distributions and such, so you know why these dates are looking more likely. Can we see the flat view again? Yes, you want to see this. This is, as you can see, it's starting to, like, the points where the chart kind of starts to become indistinguishably flat they're approaching like the ends. So it started out super pinched and then it's getting wider. I mean, it didn't seem pinched because, you know, it was scaled relative to the full length, but it is gradually starting to look a bit flatter. Wow. Anyway, thank you for the distraction. I'd gone on off a random tangent about the many worlds interpretation, but I do think that this is a relevant way of thinking about it, of how did that get entered? 6. Yes, it did. Okay. Yeah. June is pretty much out. Yeah, it's not looking great for June. It is interesting that we've like, because when we started, the most likely outcome was July 1st. So like we've got an expected date of the 15th right now is quite a deviation. But we're not done yet. Like it could possibly be, you know, the 29th. It won't be, but you know, May 29th. But it won't be. Like I can confidently say that because of, you know, everything that I've explained up until now. 20s. Whoa! It's Tuesday. If I say it's Tuesday, that doesn't necessarily mean that the date is going to be on a Tuesday. That's just one of my tics. Oh, we're getting into it now. 20s. 6. That does not count for anything. That's going to bring it closer to the start of July. Wow. 5, and that's just going to push it back the other way. Even though at the start it was trending, now it's actually trending up. Yeah, I mean, this is something that I noticed when I was testing my dice app and doing millions of dice rolls. It can troll you in unexpected ways. Like obviously we kind of have a pretty good idea that it's going to be the middle of the year. Like we knew that from the start, and it's not strayed too far from that. But the ways it strays is still unexpected. Like it's still random, you know. Plus 14 days is just a 3.8% deviation. There you go. Thank you for the Thank you for the input there, the maths, because I cannot do that as we go. Oh. Another one. Whoa. July 13th. So it's did you compare IRL dice rolls to the ones in your simulator? I did a bunch of, like I recall doing a bunch of dice rolls. Like I'm just going to take a break before we do the final 10 rolls. I did do a bunch just to get a feel for the deviation. Like you can God, it's difficult to describe. Basically, dice are unpredictable, right? They will, if you roll a die an infinite number of times and it's fair, you can expect what it looks like the results of an infinite number of rolls or a very large number of rolls. But a small sample is unpredictable. It's going to look weird in ways that you don't expect. I'm pretty sure Sophie's done millions of dice rolls, full trust. I mean, just in real life without tracking it, yeah, I mean, sometimes I will roll dice as just a fidget to keep my hands busy and I mean, listen to this. Who wouldn't be, like, you know, if you've got a bunch of dice, you rattle them and you roll them and you have a good time. Just, you know, even not paying attention. Anyway, it is time for us. Let me just make sure I've still got 10 here. Yep, okay. It is time for us to do our final 10. And it's definitely looking like July. It's incredibly unlikely it's going to be outside of July. Mid-July is honestly a surprise. If I was guessing, I would have like put it within like a week or so of the thing, but you know, like random. It's random number. It's a random number. So here we go. 4. That's brings it up. 6 brings it down because 6s do not count. Wow. 3 is above the expected, so that's going to bring it up a bit. Wow. 6 brings it down as much as it can, because that is a 0. A 1 also brings it down. See, you can see like it's gone. Like we were expecting July 16th a while back, right? So oh, that brings it back up. That brings it back up. You never know with dice, but you can have, like, if you roll enough of them, you can have a good idea, but you can never know. I love them. I love these little game toy cubes that hold the universe for numbers. They're great. Okay. So, 1 die left, and here's where we're at. You can see that each possibility equally likely now, because it's a single die. I mean, I can go back and show what it was. Like, this is before our last roll. Wow. So that's our classic 2d6 that we were looking at right here. Let's go back to our thing, and then where we're at here, the 6th to the 11th. Okay. Does anyone want to make predictions? I mean, my guess was within a week of the original thing, so like 6 or 7, and my prediction is super in. Time to reenact 7-Eleven. Is anything known about the very first dice? I mean, that is a topic that I can talk about, but I'm not going to talk about it on stream because I will go on for a long time. But the short answer is we've got dice that are at least, you know, thousands of years old, and you know, even polyhedral dice that are that old. So they've been around. Here we go. Roll 73. Find out next year's RNG day date. It's 5. It wants to go right to the end. 11th of July. That is that is our date for next year. 11th of July. Bloody. Dun dun dun. Let me just make sure that the results, like I've been careful to preserve the results so we can see them. Maybe just get a ruler and make that a little more tidy. Bunnies. Wow. Hey, be tidy. There we go. Great. Okay. So there you go. 11th of July next year. That will be the next RNG day. I'll end this here and say thank you very much for watching us do this. Yeah, like I had a good time. I rolled a bunch of dice and I got to talk about dice and statistics. Oh, this was fun. 11th of July for the Dutch version of the website. Sure. Yeah, like I've got the translations all ready to go. I've got like a node script, so I'll do that in the next day or so, and I'll upload the VOD to YouTube. It will be done. I hope everyone else enjoys the rest of RNG Day. Have fun thinking about random numbers and stuff. So yeah, bye.